Hey y'all, today we're going to be talking about solving using the zero factor property. Make sure you have a strong understanding of factoring, like a really strong understanding of factoring, and solving equations. So let's start out by asking ourselves, what is the zero factor property? Basically, when you have two things multiplied together that equal zero, either A has to equal zero or B has to equal zero. So one of the two elements needs to equal zero for this to equal zero. Pretty simple, right? All right, let's look at some examples. All right, so here's three problems we're going to look at. We're going to look at more in a second, so don't worry. And notice how all three of these are set equal to zero. Your first step when solving using the zero factor property is make sure that whatever you're trying to solve for is set equal to zero. So now that we know that this is zero, we are going to set each part of this left side of the equation. So whenever there's something on the outside or anything in parentheses, we're going to set each individual thing equal to zero. So I'm going to start with that here. And that looks funny, but we're going to talk about it in a second. So we have 4 equals 0, x minus 5 equals 0, and x plus 7 equals 0. So right off the bat, 4 equals 0. That's not true. 4 does not equal 0. So this here is going to be called an extraneous answer. And so we will not include it in our solutions. But these other two parts are actual equations, so we can start solving them. They are subtracting 5, so we will add 5. These undo each other, and you'll be left with x equals 5. Now for the other one, they're adding 7, so we subtract 7. This is just like normal solving equation stuff. And we will be left with x equals negative 7. So now we need to check both answers to make sure they're valid. This is a little bit different than normal. Normally we just check one thing and we're done. But now that we have some extraneous answers, we need to make sure that our solutions are actual solutions. So I'm going to start by substituting x equals 5 into our equation. So we have 4, 5 minus 5, and 5 plus 7 equals 0. So I'm going to do the parentheses, and we have 5 minus 5 is 0, and then this is 12 equals 0. We can stop here because the presence of a single 0 will make this entire thing equal to 0. So 5 does check out. Now we need to check and see if x equals negative 7 is a valid answer. So again, I'm going to substitute negative 7 in for x, and we will see if it checks out. And then does it equal 0? We don't know. 4, and then this would be negative 12. This is 0. Equals 0. Yep, it does, because this single 0 tells us that this entire left side of the equation will equal 0. So the way we're going to write our answer, it's going to look a little bit weird, but we are going to make these bracket things. I've heard them called all different types of brackets. And we're going to put the elements that we found. So negative 7, 5. And then we're going to close brackets. And that will be our answer. So let's move on to number 2. So again, we need to set everything equal to 0. So I see m equals 0, what's on the outside. And then this, what's in the parentheses. M plus 20 equals 0. So m equals 0, that's already solved. So we can move on to the m plus 20 equals 0. We just need to solve this like normal. These undo each other, and we're left with m equals negative 20. Now we need to check. So I'm going to substitute m equals 0 into our equation. So we'll have 0, 0 plus 20 equals 0. Well, does it? It does, because of the presence of a 0. So 0 does check out. Now let's try m equals negative 20. Negative 20 plus 20 equals 0. Well, does it? Negative 20 times 0. That does equal 0. So both of these answers are valid, and we can write our solution as 0, negative 20. Now, you can write your answer in ascending order, so negative 20, 0. And both both forms will be valid. It's a common thing for mathematicians to put it in ascending order. So I'm just going to box that one, but both answers are valid. All right, pause the video and try number 3. See how you do. All right, and this is the answer to number 3. Okay, let's move on to a little more difficult problems. Okay, here are 3 more examples. So we need to factor these ones. We need to factor all of these first. Starting with number 1, pause the video and try to factor it. See if you can do it. All right, so here's the polynomial factored. So now we can set things equal to 0. So I see x equals 0 right here. I see x minus 3 equals 0. And I see x plus 1 equals 0. So let's go ahead and solve each of these. Of course, x equals 0 is already solved. We need to solve x minus 3 equals 0, and we'll get x equals 3. And then finally, x plus 1 equals 0, subtract 1, and x equals negative 1. So these ones I've already checked and made sure our answers are correct, so make sure you do that on your own time. And so we are going to write our answers using that bracket, negative 1, 0, 3. I like doing ascending order because it's the easiest to read for me personally. Moving on to number 2. So notice with number 2, it's not equal to 0. So we need to do the opposite of what they're doing. They are having negative 20, so we need to add 20 or make it positive 20. And so we will be left with p squared minus 9p plus 20 equals 0. Okay, pause the video and try this one on your own. Try to solve it. And when you come back, see how you did. And here's the solution. All right, let's look at this number 3. Number 3 is a polynomial. It's not a trinomial like the ones we've been solving. So how are we going to factor this? We're going to factor this by grouping. I'm kind of going to glaze over factoring by grouping. If this is the part that you're missing, go back to the video about factoring by grouping and watch that, and it will really help you. But for now, back to this problem. We have 3n squared plus 4 and 2n plus 1 equals 0. So we're going to need to set these equal to 0, just like how we have been. So we will have 3n squared plus 4 equals 0 and 2n plus 1 equals 0. So this problem is a little different because we have n squared. So we are going to use another property to solve that when the time comes. Negative 4, and then we're going to divide by 3 and have n squared equals negative 4/3. Okay, to solve this, we're going to use something called the square root property. There's actually another video about this if you need help on it, but for now, we'll just take the square root of both sides. So notice we're having an issue right here. There's a square root of a negative number. Do you remember what happens when we take the square root of a negative number? It's not a real number, so no real solution. All right, let's look at the second one. So here we have a normal equation that we can solve. So when we do that, we will get 2n equals negative 1, divide by 2, n equals negative 1/2. So notice here, we actually only have one solution. We only have this n equals 1/2, or negative 1/2. So when we write our answer, we're going to put negative 1/2, just like normal, and we are going to call it a day. I hope this video helped, and I'll see you next time. You got it.